Our group did the research project on the comparison of mass and density in red ellipticals and blue spirals. We hypothesized that both the mass and the density of a red elliptical will be greater than that of a blue spiral. From the dataset, our first graph shows the comparison of average masses for both types of galaxies. As you can see, the red elliptical galaxies have an average log mass of about 10.75 versus the average of the blue spirals at 10.25. This directly supports our hypothesis that the red ellipticals will tend to have a higher mass. The next set of graphs is the mass versus the density. The purpose of this graph was to check if there was any direct correlations between the mass and the density occurring, checking if as the mass increases, does the density tend to increase or decrease. One thing important to note about this is that this is the local density, or the density of the environment. However, we can estimate that the plot of the mass versus the density of the galaxy would look similar. This is due to the mass staying the same but the volume changing, resulting in a different density.
Key visualization number 1 analyzes the mass of each type of galaxy. In Figure 1 in the upper left-hand corner, the stellar mass of the galaxies is split by color. Figure 2 on the right side shows that red ellipticals in general have a higher mass than blue spirals. The average stellar mass for red ellipticals is about 10.5 log m, and for blue spirals it is about 9.7 log m. Key visualization number 2 analyzes density. In order to find out which kind of galaxy is most common, we can look at the densities of each kind of galaxy. Our plot graph shows that in high-density environments, early type or red elliptical galaxies are more common. In low-density environments, late type or blue spiral galaxies are more common. Therefore, the most common type of galaxy depends on where you may be searching. If you look in the field, a random area of the sky where galaxies are randomly scattered, you will find many blue spirals. If you look near a rich cluster, you will find more red ellipticals.
In conclusion, with our previous knowledge, we expected to find that red elliptical galaxies have more mass than blue spiral galaxies, and that red ellipticals would also be denser than blue spirals. What we found is that red ellipticals do have higher masses than blue spirals. However, the density data that we used was actually the local density, which is the density of the environment. Therefore, we cannot actually use this data to claim that red ellipticals are denser. We assume that these density values pertain to the galaxies, which has kept us from making any conclusions based on the densities of the galaxies. Based on our conclusions, we have a few follow-up questions. We would like to know how the volume of a galaxy is calculated. We wanted to find the density of the actual galaxy, but realized we couldn't because we weren't given the volume of the galaxy. We would also be interested in comparing the volumes of the galaxies to their masses and densities because we found a trend in their masses, and are curious to see if there would also be a trend with density and volume.
And to end our project, we have a quick reflection. Obviously, science takes a long time to move forward, and especially in the astronomy field, the timeline for cosmic events goes into millions upon millions of light years, which is way past our lifetimes. And even though this project was only a month long, we were still able to catch glimpses of galaxies in their long, long lifetimes. And though it was not moving data, we were able to see current data. And though we were only able to determine the color of the galaxy, not exactly how it moves, because when it moves it takes years upon years, we still were able to see one glimpse, which is a true gift because of how long these processes take. Luckily, we didn't have to manipulate much data. With our research question, we wanted our data to be able to fit our conclusion, and luckily it did, because most red ellipticals are red and most spirals are blue. Overall, we think our project was a huge success, and we're excited that our question worked out the way we wanted it to.